I don't think they have the permission to like unmute.
Okay. No worries. So, everybody in the call right now, can you all just write hi once in the chat quickly? Let's get this started. Uh, yep, yep. Hi, 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 Rahul. Hi, Sahid. Hello. So, thanks for tuning in. Uh, until now, you went through overview of how Ethereum works. On the surface, how consensus mechanism works, how does the transaction works, how do you process transactions from the front end to the back end, how does contract handles all those transactions. But the core value of Ethereum lies in something called as Ethereum virtual machine. Now, EVM may sound like Ethereum virtual machine, but it's actually a software. You can think of it like a cloud-based software which has been deployed on many computers around the world. Is it clear until now? So, the very first point, Ethereum virtual machine, EVM, is not a single computer. It is a software, much like a cloud, which has been deployed on all the systems that are participating in the Ethereum ecosystem. Second thing, won't be showing much of PPT there, but we'll be having more, two-way interactions where I will explain things to you. And if you have some doubt, you can just unmute yourself and ask those doubts. So if it's possible, you can unmute yourself or you can just write it down on in the chat box, right? So let's just begin. I'll just share my screen. Mhm. So before we begin, can anybody tell me what is Turing completeness? Do they have the permission to unmute themselves?
Yeah, I mean, if they raise their hands, we can unmute them.
Please raise your hands. What is Turing completeness? Because see, you can read a lot about EVM, you can read a lot about how Ethereum works, but if you don't know what is EVM, how does it work, what is Turing completeness, it's gonna be of no use. And if you are spending 1 hour of your time, I'd suggest take something from here. No, just write down no in the chat box. It's fine, yeah. Nobody knows everything in the world. Okay. Okay. So a Turing complete machine. What is a Turing complete machine? So Turing completeness was you know uh, Turing completeness refers to any world general purpose computer capable of solving any computational problem given enough time and infinite memory. So in layman's language, any computer which is able to solve any computational work given they have enough time and memory are called Turing complete machines. So EVM is a Turing complete machine. What was the need for Ethereum? What was the need for EVM? Sorry. So as you all know, Ethereum is a distributed blockchain. Ethereum is a blockchain. How does a blockchain work? Blockchain works on the principle of peer-to-peer architecture. So when we have a centralized system, we have a single server that controls all the other systems connected, all the other computers connected to that particular server. But as Ethereum is a peer-to-peer structure, one computer can be here in India, in New Delhi maybe. One computer can be anywhere in Kerala. One computer can be anywhere in Tamil Nadu. One computer can be in Manipur. One computer can be in Beijing, and so on, all around the world. And there are millions of such computers combining their computational power together to make Ethereum such a successful blockchain. Now, there is one problem here. Since there are so many computers involved, so many systems involved at a single time, it becomes a problem, it becomes a major problem to maintain the state of that particular blockchain in all the systems. Do you understand what is state? Yes or no? Just type yes or no. If you know, just raise your hand and explain. If you don't know, just type no in the chat box. Okay. So state means at any given point of time, all the computers connected to Ethereum, they must have that particular, they must have the same, what do we say, same record of the ledger all around. Uh, so I'll just share my screen right now. Yeah. Can you enable screen sharing for me?
I made you the co-host, so you should have. Wait, let me make you the co-host again. So in this case, you can share the screen, and if I miss to notice any raise of hands, you have the power to unmute them as well.
Cool, cool, cool. Awesome. Yeah. Guys, just let me know if you are able to see my screen. Okay, so we have to open the chat window separately.
Yes, screen is visible.
Okay. Just a second, I need to open the chat window. So, in case you need to unmute yourself, in case you need to ask anything, just raise your hands and I'll unmute you. Cool. Yeah. So, just to give you a simple gist, this is a diagram. Okay, this is the diagram of Ethereum. Here we have few components. The first one is program counter, EVM code, stack, memory, operations. We have a very popular jargon in Web3 called gas. And here more gas, more gas. Then account. Can anybody explain me, like, are you familiar with stacks and memories? If you're not, I will explain you. Yes or no? Just say yes or no. Okay. So I'll explain. So stack is some are familiar, some are not. Okay. So stack is data structure which works on the principle of first in, last out. Like you can you see those jars in your house where if you put a biscuit inside, then you put some sweet in it, then you put some packet in it, and then subsequently you put another items. So the items you put first, you will be able to extract them at the most later stage. So what is this? This is first in, last out, or last in, first out. So the items which are going for the at last, they can be extracted first. So stack is simply a data structure. So in EVM has two types of account. We just established the wallet through MetaMask. So EVM has two types of account. First is externally owned accounts, and the second are contract account. So contract accounts are basically nothing but contracts deployed on Ethereum blockchain, which hold your fund. Okay, just a second. So how a transaction works in in Ethereum is you initiate a transaction. Okay, so that transaction is passed to mempool, where validators or miners can pick them to be so that they can be included in blocks, next block of the blockchain. Now these transactions, they are deployed by externally owned accounts. Now to deploy any transaction in EVM in Ethereum, you need to have some gas. Now, what is gas? Any state, any update of state or any write operation in blockchain is essentially a transaction. And to perform any transaction, you need to pay some gas fee, because uh, validators have to run computationally demanding operations to store those transactions in the next block. Now, as if you have enough gas in your wallet, that transaction gets executed, and in case you don't have enough balance in your wallet, that transaction gets reverted. Okay, so next we can skip this. See here. Signature. Okay. Yeah. So I'll just share another screen. Just a second. Guys, if you got any doubt while I'm explaining anything, just raise your hand.
Somebody has a doubt. Can you repeat what gas is?
So gas is essentially nothing but a fee which you have to pay to any validator or a miner in order to execute the transaction which you have spent. So basically what happens is any CRUD operation, any update, read or update operation which you perform in blockchain, that requires a computationally demanding work from the side of um, validator. So in compensation of that particular read or update operations, you pay that gas fee. Now gas fee depends upon uh, how much computationally demanding that transaction is. So I guess that's clear now. Please say yes or no, or I will explain it in more simple language. Look, yeah, it's clear. Fine. So I'll essentially focus on sharing much of resources which you can refer after this session to dive deeper into what's Ethereum. You all can see my screen right now.
Yep.
Yeah, cool. So this is a very nice article written by Rajiv on Securium. So it has got 101 points regarding Ethereum virtual machine. Now, if we go point by point, this refers Ethereum as a next generation smart contract and decentralized application. As we said, Ethereum is a built-in Turing complete programming language, allowing anybody to write smart contracts and decentralized applications where they can create their own arbitrary rules of ownership. We'll skip this part. We'll skip to what's interesting to us. So, Ethereum's core component. As I told, Ethereum is a P2P network. P2P network. Do you all understand what's a P2P network?
Peer-to-peer.
Yeah, it's peer-to-peer. But what do you mean by peer-to-peer?
Means you can send directly from person to person without involving a third party.
Without involving a third party, okay. Any more explanations? Yeah, it's correct, but it's not completely correct. It's partially correct. Cool. So I'll tell you what's the peer-to-peer network. So a peer-to-peer network is such a network which has no central authority. For example, consider AWS data centers. So all the computers which are connected to AWS, all the applications which are running on top of AWS, which are utilizing the infrastructure for AWS, they are connected to a particular data structure. Is that clear? Now, all those data structure, But did I say data structure? All they all are connected to a particular data center in a centralized manner. So all these computers which are connected to that particular data center send their send their data to this centralized server. Now this centralized server analyzes those data, decides what to do with this, where to forward this, and then the subsequent actions happen. But what in case that particular data center fails? That data center can be running important applications which may be related to bank, which may be related to any fintech company, or which can be of utmost importance. Now if that particular data center fails, all of those applications face downtime. This is the disadvantage of central uh, centralized data center. Further, in order to gain control of all those systems which are connected to that particular data center, a hacker doesn't need to hack in all those systems individually. But what they need to do is they just need to target that particular data center, and then they can have those informations like this. Cool. So peer-to-peer network is a type of network where there is an absence of a centralized data, a centralized server. What does this mean is every system in that P2P network maintains a copy of the whole network. Are you getting it? Every system in that particular P2P network maintains a copy partially or fully of the whole network. Now, in case if I want to download something from a P2P network, and the peer which I was using to download faces a downtime, goes out of the network at the same time. Now, due to this, in a normal scenario, if I had been using a centralized data server, my download would have failed. But now, since I am using a peer-to-peer data structure where each peer maintains the state of that particular uh, networks in a partial or full manner, now my system will start looking for another peer who has maintained that particular, who has stored that particular information which I have, which I want to download. See, now in the whole peer-to-peer, in the whole network, there will be countless of peers which will be having the same info which I want to download. So if one peer fails, I can go to another one. If another fails, I can go to the third one. If third one fails, I can go to the fourth one, and so on. So that is essentially a peer-to-peer network. Is that clear to you all? These are very basic. These are very basic. Yeah, it's like torrent. Yep. Torrent also works on peer-to-peer structure. Yeah. Rest of all, is it clear? So I hope it's clear. Now, transactions. Ethereum transactions are network messages that include a sender, recipient, value, and payload. I guess Asutosh already covered it. State machine. Ethereum state transitions are processed by the Ethereum virtual machine, a stack-based virtual machine that executes bytecode EVM programs called smart contracts that are written in high-level languages, example Solidity or Viper, and compiled to bytecode for execution on the EVM. Now, what happens is computers don't understand English. Computers generally understand zeros and ones. So if you write a program in any of those high-level languages, such as Java, C++, JavaScript, Solidity, computers can't understand those English language, those high-level languages. So the code we write in those high-level languages, they need to be essentially converted into zeros and ones. Who does that work? Can you tell me? What converts a high level language to a machine readable code? Yeah, it's compiler. Compiler converts those high level language codes into a machine readable code. Now, the same happens with Ethereum virtual machine. Ethereum virtual machine can't read the smart contracts which we are writing in Solidity. So what we need to do is we need to convert this whole Solidity code into an intermediate language which is called bytecode, which essentially means machine language instructions. Now, when EVM gets these bytecode, it goes through it, then it executes it, and then it updates the state on the whole blockchain. Is it clear until now? Cool. Now, there are a few core components for Ethereum. The first one is consensus algorithm. So what is consensus? If anybody would like to attempt, they can just unmute themselves or raise their hand. You can just unmute yourself and start speaking. What is consensus? A very big jargon in Web3. This protocol has the best consensus algorithm. This protocol has a mediocre consensus algorithm. Their consensus algorithm takes a lot of time. Can anybody define? Or should I explain? Of course, I would explain.
Suppose there is a block on a on a blockchain, there are many nodes. So before entering, so before adding a new block, all the members of the node should accept, means validate before adding it. So that's consensus.
Yeah. So basically, consensus mechanism means is a method by which all the systems which are in that particular blockchain network agree upon a common state of the whole blockchain. That might sound something overwhelming. So let me simplify it for you. Suppose there are 5 persons, A, B, C, D, and E. Now these 5 persons form a peer-to-peer network where everybody is connected to everybody. Like A is connected to all of B, C, D, and E. B is connected to all of A, C, D, and D. Right? Now, suppose they maintain a ledger between themselves, a copy of ledger between themselves, where each of them has their own copy, where they enter there who has taken how much loan from whom. Suppose A takes 5 rupees loan from B, B takes 5 rupees loan from C, E lends 25 rupees to A. So, and since all these transactions are happening peer to peer, like the lending is happening only between A to B, but this needs to be included in everybody's ledger to maintain the uniformity, to maintain the common state of the ledger. So a consensus mechanism is essentially a mechanism where with the help of which all the nodes in a particular blockchain agree to a common state of that chain, common state of the machine, which particularly means that each of the computer connected to that blockchain has the same amount, the same data in the same order, exactly same values as the all other systems connected in the network. I hope that's clear. Yes or no, quickly, please. See, if you think anybody goes over by your head, just stop me and ask me to explain again. I'll do it 5, 6, 10 times. No worries. Okay. So traditionally, Ethereum has been using a consensus mechanism, which is Ethereum had been using a consensus mechanism, which was called the proof of stake mechanism, to determine the longest chain and therefore the current network. Now, what is essentially a proof of network? So, suppose I send a transaction. Suppose I send a transaction to a validator. Now, along with that transaction, the EVM generates up nonce. Now, all the miners in the ecosystem, they compete to generate this nonce, which is computationally hard to obtain, which is computationally demanding in nature. Now, the person who finds the nonce the first is declared the miner of that particular block and is compensated for that. Getting it? Now you have to do some work in order to generate that particular nonce. So that is why this is called as proof of work. But this has been now discontinued, and we have moved to a more eco-friendly alternative, which is proof of stake. So proof of work essentially demanded a lot of computational power, due to which miners needed to run a lot of GPUs, a lot of computational powers, a lot of CPUs, demanding a lot of energy. So that was termed as hazardous to environment by many people. So that has been transferred to now proof of stake algorithm, where you have to stake a particular amount in order to be a validator. Instead of doing the work, now you have to stake a particular amount. In case you are found to be indulged in including a fraudulent transaction in the block, that stake is that stake gets revoked from you and you get punished. Is that clear, guys? Yes or no, please? Okay. Clients Ethereum has several implementations of the client software. The proof. Okay, we can skip this. Okay, so we were in the very starting of the session. I asked you guys, what is a Turing complete machine? Uh, was that clear to all? What is a Turing complete machine? Now, so Turing complete machine is essentially computer or a system which can perform a mathematical operation given it has enough time and memory. Okay. Now, Ethereum's ability to execute a program, execute a stored program is a state machine called Ethereum virtual machine. While reading and writing data to memory makes it a Turing complete system because it has both available time and available memory. Now, Turing complete systems face the challenge of the halting problem. That is, given an arbitrary program and its input, it is not solvable to determine whether the program will eventually stop running. So, in case, suppose you send a transaction to the blockchain, which cannot be completed. For example, you have just 2 ethers in your wallet, and you send like 5 to 6 ethers to your peer, 5 to 6 ethers to your friend. How can this be completed? Right? So, to predict if a smart contract will terminate or how long it will run, the constraint of the use of resources has been determined by a metering mechanism called gas. So I earlier explained what gas is. Let's move forward. So guys, if you want to learn more about EVM, this is a very good resource. Hmm. Let's move to another point. Yeah, you had established a MetaMask account in the previous uh, session by Asutosh. So you must have observed that Ethereum, uh, where is that? Ethereum, your account address is a hexadecimal address with as a 20 byte address, state transition being direct transfers of value. Hmm. So this is one of the resources which I think you must go through in order to learn more about EVM. Earlier, I had explained much about it in my PPT. Uh, we can take some doubts now because I've already explained these things: minus, blocks, consensus, state, and everything. I'll just share the link of this article in the chat box. Do we have any questions? Just unmute yourself or raise your hand or type in the chat box. I'm waiting for like 2 minutes. This is a very good resource for you if you want to dive deeper into EVM. Okay. Do we have anything else scheduled after this? Nived, if you're there.
Yeah, I'm sure.
Yeah. Do you have anything else scheduled after this?
No. Just
So
this
in
session.
case there is nothing after this, so and if there are no questions, we can wrap it up. In case you have any questions regarding EVM or Ethereum or anything that you may require to kickstart your journey in blockchain, you can reach out to me on my Twitter. I'm leaving the link in description box. Yeah, so we can wrap it up now.
Yeah, so thanks a lot, Saujam, for this wonderful session. Actually, we got like great insights from you on EVM and all. So I think Annie, let's wrap it up, right?
Yeah. If there are no questions, we can do that.
Okay, is there any questions? Yeah, there's a question here. What is the relation between validator and stake?
So, in order to be a validator in the new proof of stake consensus mechanism, you need to stake a particular amount of ETH, right? So, in case you are found as a security amount, you can say in layman's language. So, in case you are found indulged in including any fraudulent or malicious transactions in any of the block, that staked amount gets revoked from you and you are punished. So this is basically a way to avoid inclusion of malicious transactions in the block. Okay. Yeah. Any more questions? Are there any more questions? No. If there are no more questions, we can wrap it up here. Okay.
Yeah,
And guys, please go through that particular article which I shared. You'll get great insights.
yeah, I think like even if you have any doubts after this session, you can simply ask in
Yeah.
the group.
Yeah. Please reach out to me if you have any doubts.
Yeah. So, Annie, are you here? Yeah, I think yeah, she's having some network issue, I guess. So yeah, like I think let's wrap up for now. Thanks a lot, Saudam. Thank you everyone for joining for today's session. Stick on with us. There are lots of things coming in the upcoming weeks. So as I mentioned before, if you have any doubts, you can reach out to Shaurin directly, or either you can ask in the WhatsApp group that we have created. So we will reach out to Shaurin and clear that doubts for you guys. Then we might be having an open office server in the coming week for clearing all the doubts. Yeah, in the case of recordings also, I will share it with you in the group itself. So that's all from my side. If there are no doubts, I think let's wrap it up. Yeah, I think let's wrap it up. So bye guys. Thank you for joining. Let's leave.